Okay, good morning, everyone. Good morning. Okay, my pleasure to be a part of this one-day event, Industry Day on digitization. So I start with a glimpse, as Prasanna mentioned. Really, it's very difficult to manage the many things in a short time, but to give you a glimpse. Now, when it comes about digitization, everything thinks about data, data analysis, signal processing, and so on. But the question is that there are platforms and systems. If they are not in place, digitization will not happen. And more often they are missed. And that's actually a bottleneck because it relies on a heavy import. And unless that heavy import will not be sustainable, digitization will not be sustainable. It's a fact, and we have to really think about it. And it becomes more complex as time passes because technology becomes more advanced, acquisition of the technology becomes more challenging and needs much more investment. So therefore here, as per the domain that I have, I focus on three things which are very important in a chain of semiconductor industry. Semiconductor industry now has become a kind of a strategic industry, though applications are almost covering each and everything in the daily life of each and everybody. No matter where we are, what we do, at what age we are, and which part of this earth we are living. So it's almost everywhere. Just imagine each and everything here cannot work without this technology. So even what Prasanna presented cannot work without this technology. So therefore, what's very important is to three things to be in mind. One is viable technology in this domain, mission that already is established for India, how we can move in that direction, and today is a very good opportunity to discuss about it. And finally, how to get this into two sides or extremes of this chain. One side is from materials and sensors, and one side is systems. And Industry 4.0 and 5.0 is exactly a part of this chain. So therefore, I'll give you a glimpse of some of the activities in these three domains. And specifically the middle part, which is very much compatible with India's semiconductor mission. And here is only examples of the IP generation for this platform digitization. So it is not the digitization in the pure software and data, it's more about the technology and the devices. And there are specific examples which are supported, for example, by various projects, by government projects, industry sponsored, but transferred to industry or startup, and therefore it is compatible with what we are talking about. So I want to give you an example of what we developed as the first eventually IC from India, indigenous IC, which is fabricated in UMC 180 nanometer technology, compatible with SCL Chandigarh technology. And you don't believe when this IC was fabricated. It was not during COVID. It was not even near to COVID. Project actually started in 2012 with the funding from Ministry of Electronics and Information Technology at that time. And at that time, we were thinking about that, how we can have the IPs which are generated and by the design within India. So this actually goes around 12 years ago. At that time, we started this project. And at that time, we developed an IC which is compatible with the commercial IC with a lower power and a lower supply at that time. This project, of course, was ended around 2000. It was a 5 years project. So it ended in 2017. And this is completely indigenous IC. And you can see this IC sitting here on this board. And this was effectively, we called it OxySense, And it happened all before COVID. We didn't know there is something called COVID virus. So it's very important to have Indian ICs. How many Indian ICs are commercially available today? Shakti processor, Ajit processor, 2, right? How many ICs are available commercially across the world? Lakhs, definitely lakhs, millions. You just separate them. And each of them is manufactured continuously and distributed in tens of million copies. This is the strength of the semiconductor technology. It needs $1 billion investment at the beginning, and then it will continue forever, like what TSMC did, right? So therefore, here is important, looking at now what kind of ICs should be tomorrow. There should be hundreds of ICs, which are Indian ICs, and they are commercialized and produced and exported to different locations for developing different systems. These days is other way around, right? ICs are imported and then put in this. So it should become an other direction, at least at the part of areas. And this is to show that how it is possible to do that. And before this, I didn't show you, and that was 2003. It is almost 20 years ago. 20 years ago, we had, at that time I was a postdoc at IIT Bombay, and then at that time there was a project funded by TCS. And at that time, that project was talking about to develop an Indian IC, which will sit on a device which was called Silicon Locket. And it was for ECG monitoring 20 years ago. 20 years ago, we developed, that was actually a part of my postdoc. We actually designed and developed that first Indian IC for ECG acquisition, which had the minimum reported world record in power dissipation. And one of the leading companies at that time, so because of confidentiality I cannot name, asked for the IP transfer and said that we will transfer this IP from IIT Bombay to our company, and it was a US-based company. And then we will take the ownership, we will make ICs. So this is 20 years ago. And it's very important, the message today I want to give is that there should be a kind of continuity and giving value, because something which 20 years ago still was not being anticipated, actually was anticipated in this project, which will happen 20 years after now there is a semiconductor machine. But actually roots are going back to those days. The same thing which happened with the software now need to happen in this domain. And one of the new centers at IIT Bombay is actually a center which is heavily connected to industry in semiconductor mission area and covers from materials to systems. And it is called SemiX, and it's a new center. It's 1-year-old center only. And it would be nice, and it's also like as a part of centers that Professor Sachin presented, so at IIT Bombay. And they will reach there as well, some of the activities related to that center. So this is that chip. And this chip actually was used and we made a complete system out of that, which is eventually a completely indigenous, now IC also is indigenous, SpO2 measurement, which became the important part of the COVID later. You know, you don't know what happens in the future. And then in the future, of course, COVID happened, and this was a very important device everybody was using. And these are the results of the test measurements with respect to SpO2 and heart rate. Variability, as you can see, the values are very low and acceptable with respect to the technical specifications. So this is the IC. Along with that, there was another technology which is still available, and that's for wearable and implantable. So we showed that how a transmitter and receiver, again the first indigenous ICs, can be actually designed completely indigenously. These are the circuits. This is also a brief block diagram. And some of the features, for example, this spectral mask is a very important feature, and for the first time we achieved it because for implantable and wearable devices, it's prone to a lot of noise. And therefore, in medical application, you can't have noise because nothing should go wrong in measurements. So this now going back, and then after almost like 15 years, actually India semiconductor mission started to be discussed, and finally Semi-X started. But before even Semi-X started, we actually started during COVID one activity which was one of the main streams of today, artificial intelligence as opposed to natural intelligence, and how we can have the bio-inspired, again, indigenous ICs. So what happened is that this spiking neural network IC, for the first time, we used the feature of a technology which was not even used by the owner of the technology, which is global foundries. You may be familiar and know about global foundries. Global Foundry makes SOI devices, and they have a worldwide market. However, there is a specific effect in their devices, which is called band-to-band tunneling. And this effect was analyzed and started with Udayan Ganguly, who is one of the faculty at IIT Bombay in EE department. Then once he talked to me in 2019 and said that, can we convert it, it was before COVID, convert this effect into a full-fledged IC. And then at that time, actually, we were discussing about the bio-inspired computation ICs. So we started, and then COVID hit it, but we didn't stop. So we started actually use this BTBT effect, and it was a risk. So the Global Foundry supported the entire silicon. This is an expensive technology. 45 nanometer RF-SOI, they give us free silicon. Like, they saved us 40 lakhs. They just gave us this space and say that you use this effect and show this effect is working. And it actually ended up in actually the first worldwide voice edge detection, which is fully analog. This is an analog spiking neural network. And then after that, we got a lot of inputs. I remember even somebody from US just connected to me on LinkedIn and said that, can we discuss about this chip? Because I'm an investor and I want to see how, and they tell you how to move further. And then I had a discussion with him later. So this is an example how things can go in the right direction. Now, when you make these ICs, then you are able to move it further. Now, the same company now giving us a space for the scale technology and say that, okay, now you make more designs in our scale technologies. And this is the way industry in this domain actually can help to not only bring technology, but also to bring designs in their technology. And now they are actually connected, one of the industries which are connected to this center. Along with that, we also look at the systems. For example, here are two systems which are developed at IIT Bombay. One is supported by TCDT Center, another supported by WRCB. Both are centers, and both are supported by industry, Wadhwani as well as Tata Trust. And this actually has become a product which is now moving towards the startup. So it's for tinnitus patients. And tinnitus is a very important domain. Again, at this moment, it may not look very stringent, but as time passes, it is increasing because of the large usage of the various devices which are connected to our hearing. Eventually, we are not in natural mode of hearing anymore. We are continuously hearing artificial sounds with different volumes, which is not well controlled. Its control, actually, it's worse, always increasing them. And this gradually is picking up as a problem even in the young generation. So therefore, it's better to have a precaution about that. The second one is the same SPO2, but then with WRCB funding, we were able to actually develop another version of that, which is based on the reflection rather than transmission, and we were able also to pass two eventually standards, AAMI, which is for US, and BHS, which is for UK. This also now is being discussed with industry. In fact, I will have next week one more discussion with industry who is interested in this thing. Now, when you have the semiconductor technology and you have the IC design capabilities, then you can make more indigenous products. So this is supported again by METI and DSC, and this is again one of the first, because we have developed more than one, but this is the first indigenous chip for soil moisture sensing, and eventually it is for dielectric measurement. Therefore, it has other application, but actually we have used it for soil moisture sensing. And again, you see our IC sits on the system, on the probe. So this is really very important, and I believe that this can result in a huge kind of business model, as already is available. Already, I think everybody is aware of the scale of semiconductor industry and the business available in that industry. Going in the same direction, we should also look at the systems. We should not be afraid of systems. For example, here I give you one example. You may know about the time domain reflectometry, which is used for soil moisture sensing, and it is used for very accurate sensing. And the cost of these devices, which are all imported practically, goes above 1 lakh to around 10 lakhs, depending on the accuracy. However, this was actually a complete PhD project at IIT Bombay, where the complete indigenous kind of, but here we don't have any of our own IC. The probe, of course, is manufactured here, but the system is designed and developed at IIT Bombay. And then it was also tested. So this system also is available for commercialization. And this is something I really also, one of the designs that really is close to my heart, because of I know that how much effort and how precisely both signal processing and the hardware have been taken care in this system. Now going to the sensor, which is another technology which is now used by a startup. So it's eventually printable pH sensors, which can be used for various applications. We used it for agriculture application, but it can be used for other. This also was a PhD project at IIT Bombay. And it's printable. This print that you see, it is actually printed here in our own lab. And you see the results of the calibration curve, which is also published and also granted by a patent. In fact, all these outcomes that I showed you, they are either published or covered by a granted patent already. Finally, we have also TIH Foundation, and then because I have also connection to two centers specifically in a kind of spending a lot of time in these two centers. One is SemiX and one is TIH in IoT and IoE. I just give you an example of the close collaboration we have with agriculture institutes, where we actually look at the whole chain from the system development to the data analysis. And their fields are actually open labs for us. And this is very important to actually develop the culture of having open labs and working with the agriculture industry and agriculture institutes, so that we can actually nurture this culture, notion of open labs. And why I'm talking about? Because there are many aspects which are not actually tested with our own products. And when we have our own products, to be able to use them, we have to really take them to the real field. And that is one of the examples. Specifically, like in this example, we are working on the onions, and the reason we chose onion was because it is not very well taken care everywhere, and quite a technology. Usually cash crops like rice or wheat, or for example, even coconut are taken care, or sugarcane. But therefore, we want to look at the other sectors of the agriculture products. And so, just to give you a summary, I think I am on time. So to give you a summary, there are many people and many teams over years who have contributed, several labs at IIT Bombay. So therefore, I cannot name them, but just I have put some glimpse of the labs, students, collaborators, everybody. But at the end of the day, it's very important to now take it even further. And we continue. So therefore, these were some examples which are directly connected to industry, and that's why I didn't give any other example. Thank you.